Today we're going to be looking at electrolytes, those ionic compounds that are placed into Gatorade and Powerade that allow us to replenish electrolytes that are lost when we work out. And so let's talk about just a quick review first off, and something that we talked about earlier this year, but it's going to come up again, and that is what is an idea of an ionic compound. And so we hopefully remember that an ionic compound is a compound that's made of a metal as well as made of a non-metal together. We have transferred electrons, and when we transfer electrons, we get an ionic compound. And just a super fast review, if we draw a rough sketch of our periodic table here, well, that's a really rough sketch. And there's our semi-metals there. Remember, everything to the right of the stair-step line is considered a non-metal, and everything to the left of the stair-step line is considered a metal. With the exception of their hydrogen sitting up there, and hydrogen is going to act like a non-metal most of the time, as we're going to see soon. We remember that. And so a couple examples, we've got KCl, potassium chloride. The potassium is our metal. The chlorine is our non-metal. We have another example of copper 2 nitrate. Copper is our metal, nitrogen and oxygen are our non-metals. So this is great examples of an ionic compound. Diving right into the next one, that would be a molecular compound. And we remember, hopefully, a molecular compound is a non-metal attached to a non-metal. And oftentimes we have more than just two non-metals. We can have tons of them. And usually, not always, this includes hydrogen. We'll talk about when it does not include hydrogen, though. And so here's some good examples of this. And we have C6H12O6, which is glucose, or we have water, all non-metals involved there. So molecular compounds. Now, the reason why we bring this up is because this dovetails in very nicely with our talk about electrolytes, because electrolytes really are the difference between an ionic compound and molecular compound with how they behave. So here's a definition of electrolytes. And this is going to be a substance that has the ability to conduct electricity. And electricity is just this transfer of electrons from one place to another. So that's what electrolytes are able to do. They're able to conduct electricity. Electrolytes can be, now they can be a couple different things. One of the main ways we look at electrolytes is if you have an ionic compound that's been dissolved, that means it's soluble. It's able to dissolve. And we put it in water, what's going to happen is it's going to form ions. And when it forms those ions have the ability to conduct electricity. So that's one way we could tell if you have an electrolyte, ionic compound. Another one is an ionic compound that maybe is insoluble. It won't dissolve in water, but what we can do is we can heat it up. If we heat it up and melt it, then it becomes what we say molten, and it will have the ability to conduct electricity in that state. Now, and one of the other ideas that our electrolytes are typically, and we did test this yesterday, is they're usually acids or bases. And we haven't talked a whole lot about acids or bases, although we've used quite a few acids this year. An acid is going to be something, for a simple term, that gives off hydrogen ions in solution. And so a real common acid might be hydrochloric acid that we've used in this classroom. And a base is going to be something that gives off hydroxide ions in solution. And a really common base that we've used this year is sodium hydroxide. Now, when these guys are placed into solution, they ionize or break up, and we'll be talking about that next. And so they have the ability to conduct electricity. So next up, let's talk about a non-electrolyte. This is something that that will not conduct electricity. Non-electrolytes typically are molecular compounds. As we said before, molecular compounds are nonmetals plus nonmetals, including hydrogen usually, except when it's in an acid. So non-electrolytes, let's say yesterday's lab, or the lab that we did the other day, we had sugar water. Now, sugar water would be considered a non-electrolyte because it doesn't have ions. Now, different types of electrolytes, as we determined in our lab, we could have strong electrolytes. Now, strong electrolytes are going to be things or solutions that have high concentration of ions. So if I was to draw a little model here, and let's say we had some water here, and we put some sodium chloride, let's say some sodium chloride solid into this, we would have lots and lots of sodiums and chlorines and sodiums and chlorines, and we just have lots and lots of these guys. And the more we have, the more concentrated this becomes. And they all break up. Okay, and that would be a strong electrolyte. Now, a weak electrolyte would be something with lower concentration of ions. And to use the same model with some water in there, maybe we just have a few sodium ions and chlorine ions. And we still have the ability to conduct electricity. It just isn't going to conduct electricity as easily. We have a low concentration of ions, not as many. Now we should talk about, lastly, ionization. And this is when we have a solid that is placed into a solution and it dissolves to form ions. So let's talk about how to do that. It says, the example, show how lithium chloride solid ionizes. So we're going to take lithium chloride as a solid, just like this, and we're going to put it into water. I'm not going to show the water. Trust me, we put it in water. Now, lithium chloride is soluble. It will definitely dissolve. And what's going to happen is it's going to break up into ions. It's going to break up into the lithium ion and the chloride ion. And because these guys are dissolved in water, we're going to write them as aqueous, AQ. Now, all we need to do now is look up the charges when each one of these forms an ion. Now, lithium is in group 1A, makes it an alkali metal, and hopefully you remember that everybody in group 1A, when they form ions, are 1+, because they lose an electron. Chlorine is in group 7A, it's a halogen, and everybody in group 7A, when they form ion, gain an electron, so they become 1-. And that is how we write lithium chloride to show its ionization. The next one says show how iron 3 chloride ionizes. So once again, we're going to write the formula FeCl3 solid. And we're going to break this up into two ions. So we're going to break it up into the iron plus the chloride. AQ, AQ, because these are both aqueous, are being dissolved in water. Again, chloride is in group 7A, so it's going to be a 1- charge. Now, iron is a transition metal, which makes it have the possibility of having more than one charge. But if we look back over here, we can see that right here we have a 3, and that 3 came from the iron. So this has to be a 3+ charge. Because remember, we did do the crisscross method to find out how do we get to a neutral solution. So there's how we write the ionization equation for iron 3 when it's ionizing in water. So once again, just to summarize, we have electrolytes, which are ionic compounds, which we can have them dissolve in water. We have non-electrolytes, which are things that don't conduct electricity, usually molecular compounds. And we can write ionization equations, so we just need to look up charges of each one of the ions once we break them up. And that's the end of the video today on electrolytes and ionization.